Hi guys, welcome back. So this is part 2 of the Weekend Dev Challenge 10, and so let's see the problem statement. So the problem statement tells us to implement k-fold validation logic. So we have to implement k-fold cross validation. So there is this concept called k-fold cross validation. So what are we doing in this? We're splitting the data set into k folds, like k parts. Each part of equal size. It is called as fold. So then after splitting it into k parts, we're using k minus 1 parts for training and remaining 1 part for testing. So, and this shuffles. So when you split the data, and this happens for k times. This is an important note. This happens k times. So we're splitting the data set into k parts, splitting and taking that k minus 1 for training, one remaining 1 for testing, and this runs k times. So every time it is shuffled. So then we are shuffling, so every time it is shuffled. So then we have a proper distribution of data to calculate anything which we require. So this is for cross validation. So let's see, this is what they've explained in the problem statement. Now the task is to implement a custom k-fold cross validation, splitting the dataset into k cross validation using NumPy. So okay, what we'll receive is two NumPy arrays, one integer k that is represents the number of folds we have to do, and then boolean shuffle. Okay. So this is what they've given. Now let's look into the code. So the first line code says import numpy as np. Then we are defining a function k cross validation, taking input, one is x, that is array, one more is another array, then k is equal to 5. So we are splitting the data set into 5. The k is 5, so we are using the four parts into training and remaining one into testing. Then we are enabling shuffling. So what does this do? It keeps shuffling. So the same data doesn't get trained and tested every time. It keeps changing to get a good result. So then we are finding the total number of samples, and then we are giving indexes for each of the sample. So it becomes easy for us to shuffle. Now we are telling if shuffle is equal to true, then we have to shuffle it randomly, random shuffle using based on indices. So this is why we gave indexes here. So we are enabling shuffling using indices. So then we are dividing the dataset into k parts. That is fold size equal to np.fold. Now we are dividing the data into k parts. K is the whatever value is given, that is 5, and then number of samples which is calculated here divided by k. So let's say if there are 10 samples and k is 5, so we have two values now. Fold size is 2. So then what does this line do? Let's say there are 11 or 12 samples and then k is equal to 5. So we don't have equal division there. We have in first two we have 5 5, and then we have 2 or 3 left. So then this comes into picture. So we have a separate array created for this. Okay. So now we are creating a string for split, and we're keeping the current as 0. This is for iteration. Now we start each and every iteration. We start iterating each and every fold. So the start would be equal to current, which is equal to 0. So it starts from the 0th term of every array. Then the stop would be 0 plus fold size. The fold size is 4. Like I said, if it is 10 divided by 5, it would be 2. So the fold size would be 5. And in this fold size, the fold size would be 2. So 0 plus fold size is what it is said. Okay, so yeah. So we are dividing the test indices, dividing the data set into test and train. So test indices would be 1 where start of stop, and then remaining into train indices. So we are adding everything and making it into train indices, remaining everything. So now that splits contains both train indices and test indices. Now we are stopping the current. Then we are retaining the splits. Okay. So now let's see what happens when I run this code. I have given two inputs in the main, and I've given the splits k equal to 5 and shuffle equal to false. Here I have not given shuffling. So let me run it once and see. So here, yeah, so there are for totally 5 folds, and train indices is given, test indices is this. So what is there? Here it had one. So here it had 10 terms, but here we have 8 and remaining 2 as test indices. Because k is 5, we have 5 folds, and every time the test indices must be different. You observe this every time the test indices. So every time the test and train both are different, and they don't have anything in similar. So this is how we split the data into, this is what k cross validation is, k fold cross validation. And I hope you guys have learned from this video what k fold cross validation is and how to implement that. So if you want to practice this, then head to CodeChef platform right now and practice. Give it a try. This is easy. You will figure it out. So that's it for this video. I'll meet you next video. Thank you.